The next lesson from Unit 3 is Lesson 6. And we are going to be solving, let's make sure you guys can see this. There we go. We are going to be solving radical equations. Solving radical equations. Okay, so every time you hear the word equation, you should be thinking it's going to have an equal sign. And radical, we all know a radical is this symbol here. So these are equations that have radicals in them. Let's take a look at number 1. The directions will say solve. So we've got the square root of x plus 2 is equal to 3. So our goal here is we have to find out what x is equal to. You can use trial and error if you want. It may take you a while. Well, this one's not that difficult. You could probably use trial and error. But in Algebra 2, there's a way that we solve this. So in order to get this x by itself, the first thing I need to do is to get rid of that radical. This radical needs to go away. So it's the square root. Remember, if there's no number there, it's really a 2. It's the square root. So in order to get rid of whatever root it is, you're going to raise it to that power. So if there was a 3 here, I'd be raising it to the 3rd power. If there was a 4 here, I'd be raising it to the 4th power. But because it's a square root, I am going to square both sides. And remember, in algebra, whatever we do to one side, we have to do to the other. So this power cancels out with this root, and you're left with the radicand, whatever's underneath that radical sign. So I've got x plus 2 is equal to 9. 3 squared is 9. It's not 6. It's 9. You're doing 3 times 3, not 3 times 2. Then I'm going to subtract 2. 3 minus 2, that's giving us 7. So I've got x is equal to 7. Before I box that out, I probably should have checked it. You don't really have to write out your check, but you should mentally check it. You're going to take that 7, substitute in. 7 plus 2 is 9. The square root of 9 is 3. That checks. Number 2. Let's lift that up. There we go. We've got the square root of y plus 6 minus 5 is equal to negative 3. So the square root, let's make sure that radical sign is not over that 5. I don't want you. There we go. So the square root of y plus 6 and then minus 5 is equal to negative 3. Now for this problem, you've got this negative 5 that's outside of the radical. That's what you need to move first. If you have other things around the radical that's on the same side as the radical, that's what you're going to move first. Usually I check here and then I check here. There's nothing out in front of this that I've got to move, but I've got to move this 5. That's what I'm going to do first. So I'm going to add the 5. That cancels. I'm left with the square root of y plus 6 is equal to 2. So again, I'm looking here. I've got my square root by itself. So my next step is to get rid of the square root. So I'm going to raise it to the 2nd power. Whatever I do on one side, I have to do on the other. So this power cancels out with this root. I'm left with the radicand, which is what's underneath that radical sign. Y plus 6 is equal to 4. And then now it's just solve a one-step equation. Subtract 6. I'm getting y is equal to negative 2. And let's check that. If I take that negative 2 and substitute in, negative 2 plus 6 is 4. The square root of 4 is 2. 2 minus 5, that gives us a negative 3. That checks. So y is equal to negative 2. All right, let's take a look at number 3. I've got 3 times the fourth root of y minus 5 is equal to 6. So 3 times the fourth root of y minus 5 is equal to 6. So this time I've got a number that's here. I don't have a number after the radical, but I have a number right in front of that radical. So if you heard me say the problem aloud when I wrote it, I said 3 times the fourth root of y minus 5. So in order to get rid of this number, because I have to get this radical by itself, I've got to move this. So I need to do the opposite of what's happening between the 3 and the fourth root of y minus 5. So this is 3 times the fourth root of y minus 5. That means I'm going to divide. Whatever I do on one side, I'm going to do on the other. That cancels. I'm left with the fourth root of y minus 5 is equal to 2. Okay, now I've got the fourth root. I've got to get rid of it. So to get rid of that fourth root, I'm going to raise it to the fourth power. So I'm going to rewrite this as I'm going to just raise it to the fourth power, and whatever I do on one side, I'm going to do on the other. So this power cancels out with this root. I'm left with the radicand, which is y minus 5. And then it's not 2 times 4. It's 2 times 2 times 2 times 2, which gives us 16. So I've got y minus 5 is equal to 16. I'm going to add 5. I'm getting y is equal to 21. So let's check that. Well, let's bring that down. There we go. 21 minus 5 is 16. The fourth root of 16 is 2. And then 3 times 2, that gives us 6. So that checks. Next one. Let's take a look at number 4. I'm going to move this. There we go. All right, number 4, we've got, this is going to be set up a little bit different to start off with. Now I've got this expression in parentheses, and then I've got this rational exponent of 1/4. So our first step is to take that rational exponent and write it in radical form. This becomes the fourth root, because remember, this bottom number is the root. This is the exponent, or the power. So I don't need to put 2x plus 1 to the first. I don't need to do that. And that minus 1 is on the outside of that radical. That minus 1 doesn't go underneath. Okay, let's go through and solve here. The first thing I need to move before I raise it to the fourth power is I've got to move this number. I don't see a number out in front here, but I've got to move this one. So let's add 1. I've got the fourth root of 2x plus 1 is equal to 3. Now I have to get rid of that fourth root. So I'm going to raise it to the fourth power. Whatever I do on one side, I have to do on the other. So this power cancels out with this root. I'm left with 2x plus 1. It's not 3 times 4. It doesn't give us 12. It's 3 times 3 times 3 times 3, which gives us 81. Then I'm going to minus 1. I've got 2x is equal to 80. Divide both sides by 2. I'm getting x is equal to 40. So I'm going to check that. I'm not going to check it here in the original. I'm actually going to check it here in radical form. So 2 times 40 is 80. 80 plus 1 is 81. The fourth root of 81 is 3. That's this piece right here. 3 minus 1, that gives us 2. That checks. number 5. Let's lift that up. There we go. Number 5, we've got 2 times y plus 6 raised to the 1/2 minus 5 is equal to negative 3. Now this is very similar to number 2. There is one, well, there are a couple of changes. One, it's in rational, there's a rational exponent. I've got a fraction as an exponent, and then I've got this number out in front. So I have a number out in front and I've got a number after it. So, well, before we do anything, let's rewrite this in radical form. So I have 2 times the square root of y plus 6, and then minus 5 is equal to negative 3. So I need to move 2 things. I need to move this 2 and I need to move the negative 5. The first number you move is that addition or subtraction. So we're going to move this subtraction first. Let's add 5. That cancels. I'm left with 2 times y plus 6 is equal to 2. From here, I've got to move this 2 that's out in front of the radical. So let's divide both sides by 2. I've got the square root of y plus 6 is equal to 1. Now I'm going to square both sides. I have to get rid of this radical. So let's square both sides. I'm squaring it because that's the root. So this root cancels out, this power cancels out with this root. I'm left with y plus 6. It's not 2. 1 squared is 1. And then I'm going to subtract 6. I'm getting y is equal to negative 5. And let's check that. We're going to check it up here. Negative 5 plus 6 is 1. The square root of 1 is 1. 1 times 2 is 2. 2 minus 5, negative 3, that checks. Okay, let's do one final problem. Number 6, I believe we're on. Yep. All right. I've got, now this one is going to have square roots on both sides. So I've got the square root of x plus 2 is equal to the square root of negative 3 plus 2x. They're both square roots, so I'm going to square both sides. That's all I'm going to do here. This one is actually really not that difficult to do. You're just squaring both sides. When I do that, I'm left with x plus 2 is equal to negative 3 plus 2x. You're just left with that radicand, whatever's there. All right, I'm going to start moving things around. Let's start with the variables. This is solving a multi-step equation. I'm going to subtract x. I've got 2 is equal to negative 3 plus x. Then I'm going to add 3. I'm getting 5 is equal to x. Now I'm going to check this. Let's see what happens. I should get the same on both sides. 5 plus 2 is 7. Now 7 isn't a perfect square, but I can leave it as the square root of 7. So I should be getting the square root of 7 here. 2 times 5 is 10. Negative 3 plus 10, 7. Matches. Square root of 7 is equal to the square root of 7. And that is solving radical equations.